Right. But wait a second. I just need to see something which is happening here. Okay. I need to take full screen. All right. So a constant is force of this. What is H? Now we know that gravitational potential energy is the first input, right? So 600 times 80 times 9.85. Okay. So this is the total energy we got. And this is 470880 joules. And then we need to find this H. So it means, I don't know at Q whether it has stopped or not. It is at rest. It means gravitational potential energy is going into, like the input one is going into the work done against resistance plus the gravitational potential energy as well. So, well, the distance is given. So we have the force times 1.5 kilometer is about 1500 meters, plus this is what we need to find, and this is what we have found already. So this is gonna be 470,880 minus 300 times 1500, and we got 20880, and then we're going to do mgh again. So divided, this we'll divide it by the mass, which is 300, and then we divide by 9.81. So that's around 7.1.
Mass is 600, sir.
Mass 600. Oh no. That's going to be even smaller answer. That's 3.5 then. Pretty good actually. Not bad. All right. Now going to 18, an object of weight 15 newtons pulled along the horizontal surface. The object pulling, okay. All right, fine. So it says, what is the power to move the object? So power, the force and the velocity have to be in the same direction. So first of all, we need to find this. This is 12 cosine of 30. And then this would be about power equals to force times velocity. Is there something like the force pulling the object is this at 30? Okay, so it has to be F12 cosine 30 times 2. Let me try to find it. Second, please. 12 cosine 30 times 2. Okay, so this comes out to be 20.8 watt. And I think that should be the correct answer. Pretty simple here. And now let's go to this. The spring constant of force spring are determined by plotting the graphs, right? So which order decreasing spring constant? So we can actually find every one of these. So for the first one, force is 10 divided by 5, so it is 2. For the second one, 20 divided by 4 is 5. Third one, 100 divided by 0.1 is 1000. And fourth one is 10 divided by 0.5. What that might be? 20. So third is the, so okay, so that's the first answer is correct. Now going to, oh, how much space they've given for this? Why? Okay, which shaded area represents the work done during the plastic deformation of the rod? This is between force and extension. Plastic deformation is happening after this point, I think. Somewhere here, right? Right. But we need to find the area under the graph, but the graph is flipped. So it means we have to find this area, not that area. So this means, where is this? Where is this? Has to be C. Okay, pretty simple here. And now going to the next one, 21. Two identical waves produced at source P and Q. The waves travel along different paths to reach point R. Both waves have a wavelength of 6. And this would actually mean, what is the phase difference between waves when they leave point P and Q? So both waves have a wavelength of 6 and the waves are in phase at R. Okay. So first of all, we're going to find the path difference. The path difference has to be 100 minus 80. That would be 20 centimeter. And it is equal to n lambda. So n will be equal to 20 divided by 6. So 20 divided by 6 is about 3.33. Okay, now let's understand this. Okay, so it means that actually one wavelength is equal to 360 degrees. So a wavelength here was 6 is equal to 360 degrees. Then 3.33 would be how many degrees? You cross multiply. Okay, let me move it here so you can see 360 times 3.33 divided by 6. So that's around, what is this? That's not fair. So I'm getting an answer of around 200. But there's no answer like that. Shouldn't be like this. I made some mistake here, I think. So let me try again. 100 minus this is 20 divided by 6 is definitely 3.33. And then we have like the phase difference between, but they must have said something else as well. 120, 0, 60, 90, and 120. Why not? Let me think about it. Why? We have a path difference of 6 centimeter. If they had 1, it would be 360 degrees or possibly 0 degrees. Then 3.33, path difference of 3.33 should give us the right answer for some reason. Let me try again. 360 times 3.33 divided by 6, 199 point this. Right. Two sources point the wave different paths. But it doesn't say whether it's like, let's try it like this. If at like n be 0.5, and 0.5 is like 180 degree path difference, right? This is beyond that, for that matter of fact. So if I was like finding, let's say this is just 1n is 360. If this is like 1, this is 360. If the n is, I'm comparing wavelength, but this is n. So this is 3.33. So let's try this one. See, that's 360 times 3.33. That's 198. No, that's not, should not be like that. 198 gives me like 1200 degrees. 1200 degrees doesn't make sense, right? Because it's not much of a difference here. Okay, let's try 1200 degrees. Why would it give me 1200 degrees? Difference. So if there was n was equal to, let's try it with a trick here. So if there was like, there is no angle as 1200 degrees, so we can try as 1, 2, 3, and so on, right? Let's try that. 0 would be 0. If this is 0, this is 0 would be 0, the first one. Then after 1, it will be 1200. After 2, it will be 600. I'm just dividing it with all the n's so that I get the right one. So 1200 divided by 3 is 400. 12 divided by 4 is 300. 12 divided by 5. 12 divided by 6.
By 10.
Yeah, it's 10, right? So at 10, I would get the right answer, which is D, right? So I have to check again and again. This is also a very tricky question, actually. So basically what I did was I checked out that, okay, if let's suppose what I did was I'll explain it again because this might be, very tricky for you. So I said the path difference is equal to 100 minus 80, so I'll get 20. And then path difference is n lambda. So I tried to find n with, this is as the wavelength is this. So n was 3.33. And I know for the fact that when n is equal to 1, right, it is equivalent to 360 degrees. So 3.33 would give me like 1200 degrees, right? Then because none of the answers were here, so what I did was I checked at what n the correct answer will come. So I divided, because n is equal to 0, 1, 2, and so on. So I divided by 0 first, it was 0, and then so on. So I know that when I divide 1200 by 10, when n is 10, it means that this is the point when I'm going to get this answer right here. Is it clear? So that's fine. Now,
Sir,
yes.
there's a video about this question. They multiply 1 over 3 by 360, and that gives you 120.
1 upon 3 by 360?
Yeah.
What is 1 by 1 upon 1 divided by 3? 0.33. Yeah, basically they did the same thing actually. You know why? Because what they did was they took n as 0.33, then 1.33 and 2.33 like that. They've also checked it like this then. Until they get the answer. Do you understand what I'm saying?
Yeah.
Either you do it like this, so that it's fine. Now, 22. Which point on the graph is the center of the compression? It's a longitudinal wave. I just want to tell you, this is a pretty, simple question. When you look at a longitudinal wave, right, it has compressions like this, and then it has rarefactions like this, and then compressions again. What happens is that how a rarefaction happens because the points are moving on like this, right? And when the particles basically compress each other, that's where the compressions are, right? This means that at the center of compression, there has to be absolutely no displacement at all, right? Now, I would say that actually this should be like there's a maximum displacement to the right, which means A would be the point where you have the maximum displacement to the right. B would be the point where there's no displacement, which is this point. C would be the point where it is to the left, like this. And D will be the point where it is to the right again. So D is here. So let me try. Let me tell you, this is A, this is B, this is basically A, B, C, and D. So this means that B has to be the point where there's no displacement at all. Do you guys understand this? Basically, you just need to see where the particles are moving. This point shows to the right, this point shows to the left, and between the right and the left, because when you go right from here and left from here, you should end up at the center, which is B. That's why. D can't be the point because D is the next point that moves here. It's right, left, like that. Now, a stationary wave is formed between two identical source waves. Microphone is placed at the position of maximum loudness. That means the antinode. It is then moved along the stationary wave from the first position of maximum loudness to fourth position of maximum loudness. Okay, so the microphone moves a distance of this speed. What is the frequency? Now, you should know if this was antinode, there was another antinode, there was another antinode, this is the fourth position, right? So between one antinode to antinode, it is half lambda. Between this is also half lambda. Between this also half lambda. So the total is going to be 1.5 lambdas, right? And the microphone has moved to this whole distance as 12 centimeter, which means 12 divided by 1.5 means that the lambda is 8 centimeter. Now, what we're going to do, V is equal to F. V equals to F lambda. Speed is 330. Frequency is what we need to find, and 0.08 because we got to change it to meters. 330 divided by 0.08, that is 4,100. That should be this answer. Now going to the next one. So, okay. Ambulance moving directly towards, the ambulance decelerates as it approaches the observer and then accelerates after it's past the observer. Okay. So there's an observer, the speed is reducing and then the speed is increasing. When it is moving towards the observer, you have F naught equals to Fs times V over V minus Vs. This is Vs, by the way. And this will be F equals to Fs times V, V plus Vs. Now, in this one, this is reducing, which means that the overall frequency observed, because if it reduces, right, then the denominator is bigger, which means F naught has to be smaller. It should get smaller. So it is decreases and decreases. These are wrong. And then when it is moving away, this becomes like larger. The greater it is, then it means denominator greater means this will again be smaller. So it decreases again. So it has to be A then. Now, microwaves in a vacuum travel at speed x has a wavelength of order y. What are the speeds and possible order of magnitude X-rays in vacuum? So that's a rata question, you know. So a lot of rote learning is required. Speed. Microwave in vacuum travel at speed x. So it will have the same speed. That should be the correct answer. And the wavelength of microwaves are basically 10 raised to power 8. That is correct. This is basically you need to learn the order of magnitudes here, all right? Now, going to this one. What is the distance between X and Y? So this has to be an antinode. Why won't it work? Okay, so this is antinode, so distance has to be half lambda. Pretty easy. Some questions so easy. They're like, chalo mufti marks. Which wave behavior is shown in the diagram? That's diffraction. Pretty easy. 1 second question. And then which change in the apparatus will increase the fringe spacing? So it is basically AX equals to lambda D. So this means that A in this is Q. Source of light, it doesn't really matter. X is the fringe spacing, lambda will be lambda, D is R. So we are looking at X. So let's make it the subject. And now let's see what they have. So decrease the distance p. It has nothing to do with this. This distance is not even, we don't have any concerns. We only look at everything that happens after the double slit. Okay. So then basically it says decrease the distance q. If we decrease the distance q, x is going to increase. That is the correct answer. Decrease r, this is directly proportional. That is the wrong answer. Decrease the wavelength, that is also the wrong answer. The direct proportion is right there. Okay. Now, light of the single unknown wavelength and the blue light of single wavelength are both incident normally. Unknown wavelength and blue light of single wavelength both incident normally on diffraction grating. Two diffraction patterns are produced, one for each wavelength light. The third order maximum blue light occurs at the same angle as second order maximum unknown. The wavelength blue light is this. Okay. N1 lambda 1 equals to N2 lambda 2. We don't have the wavelength of that, right? So third order of blue, which has the wavelength of 480, is basically overlapping with the second order of unknown wavelength. So this is pretty simple. So 3 times 480 divided by 2, that's going to be 728. Okay, then. What is, okay, we don't want to do this. No electric field, no electric field. Which two units are used to define the Coulomb? Coulomb is charge is equal to I times T. Ampere and second, I believe. What is this question even? A mobile phone battery is charged by connecting to constant potential difference of 5. After 1 hour, the initial current slowly decreases to 0. What is the best estimate of energy transferred to the battery during the time of 2 hours shown in the graph? So first of all, I want to know what is the area under the graph. So charge is current into time. So if I multiply time and charge, a current, it means the whole area gives me the charge. So let's find that. 0.5 times, oh, this is actually, do we have to convert hours? Let me think about it. If it's an easier way, but I think we have to convert it. 1 times 60 minutes and 60 seconds. So that would be the area of the first figure, and the second figure will be half times 0.5 times, this is also 1 hour, 1 times 60 times 60. So add it all up over here. 0.5 times 60 times 60 plus 0.5 times 0.5 times 60 times 60. So that's 2700 coulombs. Okay, now we want to find the energy. So energy is basically is it even fair, Energy is basically voltage times charge. But there is no voltage, there is a constant potential difference of 5, right? So 5.0 times 2700. Where is my calculator? Come here. 5.0 times 2700 should be 13,500. That's 14,000. That should be the answer, my friends. Pretty simple here. And then a length of wire is connected to electrical circuit. The current is wire is measured. Which change on its own could increase the current in the wire? So resistance is equal to rho L upon A. Whenever length of wire is coming here. So first of all, resistance is voltage over Correct. So we need to see which is directly and indirectly proportional. If we increase the length, the current will reduce. So that's not the right answer. Increase the radius. If you increase the radius, they are directly proportional, the current will increase. That has to be the correct answer for sure. Increase the resistance, nope. Increase the resistivity, nope, because they're all inversely proportional to current. Okay. Now, the cell is described having electromotive force of 6. What does that mean? Okay, we need to look at the definition. So that means 1 coulomb charge always dissipates 6 in the internal energy. No way. EMF is the total. 1 electron gains 6. Why is this related to electron? 1 electron has nothing to do with 1 charge. 1 charge is many electrons. There is a potential difference 6 applied across any external circuit. That's wrong. Some will be lost in the internal resistance as well. When 1 coulomb charge passes through the cell, 6 joules of chemical energy is transformed. That is correct. Now, then, okay. Now, 36. The diagram shows the network resistors. What is the total resistance network between X and Y? Whoa. This section is R. This section is 1 upon R plus 1 upon R equals to 1 upon R. That makes it R by 2. Okay, you can check. This section will be R by 3, right? Now they're all in series, so we add all of them. R plus 2 plus R plus 3. And what you do? Let's see what you get. 1 plus 1 by 2. Oh no, 1 plus 1 by 2. What is this? Plus 1 plus 1 by 3. Is that even an answer? 11 by 6. Yay, you get it. Okay. Now 37. What is the potential difference across 180? Why is this even a question? I tell you why. It's pretty simple if you want to find V out, right? Here. So what you do? Always put the resistance on top, add all the resistance at the bottom together, if they're all in series, by the way, and multiply by the total EMF. That's how it works, okay? That's potential divider. So 180 divided by 120 plus 180 plus 150, and then you got to multiply 6. That has to be 2.4, my friends. B. Very good. Pretty simple right there. And potentiometer. What is not necessary requirement to determine the EMF of cell X? The EMF of cell X must be lower than the EMF of cell E. That is absolutely wrong. It's not required. The internal resistance, I tell you why. Because if it is lower than this, it doesn't matter because it is going to go way before, it's going to way before here. It doesn't matter. What is, well, no, wait, it is required. Because if this is smaller than X, then the wire will go beyond the length of QR. So we can't do that. Internal resistance X must be known. That's wrong. This is the only thing that's not required. I tell you why. Because when it shows you a null point means that in this galvanometer, the current should be 0. If the current is 0, then the internal resistance here, which is equal to IR, would have 0 loss because current is 0 times R will give you 0 loss. That's why. And I also wrote it for you back then. So you should always, remember to check it out. That's at the end of the notes that I provided. Okay. Now, the nucleus of uranium-235 undergoes a series of decay. During decay, 2 alpha particles and 1 beta particle are emitted. Okay. As a result, nucleus Okay, so it's saying uranium-235 92 decays into actinium. I don't know what that is. So it emits alpha particle, another alpha particle, and a beta particle. And I don't know what that is, beta minus. Okay. And what is the correct notation? So you add everything on the top. 235 equals to x plus 4 plus 4 plus 0. So 235 minus 8 is, who has the best mental math here? The calculator does. 227. So it's 227 here, and then you add all of this here. 92 equals to x plus 2 plus 2 minus 1. So 4 minus 1 is 3, and 92 minus 3 is 89. What is the answer? Where is it? Where is it? 227 and 89. That has to be the correct answer. Which particle is a fundamental particle? Hadron is not a fundamental particle, neutron is not, proton is not, only electron because it is a lepton. Ta-da! Now, answering all your questions. Please state the number, the question number, and I'll tell you what to do.
So can I send them to you on WhatsApp?
What will be, okay, so you want to do what?
I just wanted to send you some questions on WhatsApp.
Okay. Sure. Wait a second. So somebody actually asked me in question number 25, so I got to go back, okay? Then I'm going to answer your question as well. How good the weather is in Lahore today. Okay. Now, so somebody asked me, doesn't Y mean that it's already has a wavelength of 1 into 10 raised to a minus? So when it's in 10, it is, so option B is the answer. No. Basically, what you need to understand here is that when you say the wavelength of, microwave, it says, right? Okay. So basically, you should remember, yeah, you are order magnitude X-rays. Basically, you should remember that it says microwave has a microwave in vacuum travels at speed x, right? So x is same, and then it says have a wavelength of y. Okay, so we know that microwave, let's suppose, has a wavelength of y, right? So whatever it is. Now, then it says what are the speed and possible order of x-rays? So x-rays will have the same speed, but what will be the magnitude? Because microwave is taken as 10 raised to power minus 4 meters, or minus 3, you can say, right? Minus 3, minus 4 is fine. So when you have microwave this, and X-rays are taken like 10 raised to power minus 12, right? So basically the difference between these two are 10 raised to minus 8. So you got to remember this. You got to remember both the wavelengths. You take the difference because it's round about 9. Well, you can take it, microwaves can be much longer than this. So it could be like 8 as well. That's why the best possible answer is this. All right. Yes, exactly. Okay. Manometer is, yeah, well, I'm not too sure about. I think it is still there. It's not very say evident They haven't written anything about it, but because there's a pressure difference, so manometer has to be there. Okay. Munib, you can send me your questions, please.
Yeah, I sent him already.
Sir, do I stop the recording?
Yes.
Recording stopped.
Is there something you guys want to ask? Please go ahead.
Tips for electricity practicals.
Tips for electricity practicals. Yes. So the tips for is that let's suppose usually, you know, in the practicals, they would give you something like a diagram like this. Okay. Now, what is the most complex diagram I've ever seen? I've seen networks of resistors like this, and then they might give you a resistor with X and maybe like this, and a voltmeter here, I don't know, like that, right? And they say change X. So if there's a very complex situation like this, right? So what you're going to do is, yes, Daniel, you might be right about it. But we don't know because the syllabus changed, so I really can't comment on something that I'm unaware of. So, so what you do is always try to first move your finger along this path and then put the first resistor, right? And then you can pick one path at a time like this. Okay, so you mark like this, and then you can go with the second path like this and the third path. Do you understand what I'm saying? So never ever try to go through all paths at one time. And once you have done the inner section, then you start connecting the voltmeters. Is it clear? Wheatstone Bridge is in A2. It's not in AS. Now, so this is okay. Let's suppose there's something you can't do. You can't do this. All right. You can't set up the experiment. It's not coming up. So first of all, you can always take supervisor help. Okay. Supervisor help is -1 for minor and -2 for major. Okay, Nusha?
Yeah.
And if that comes, you should remember -1 major means a -2 means that you can't do anything. And even if he sets it up, make sure that you fight for your rights. Say, please do -1. Okay. Sometimes there's too nice. They can actually not cut your marks as well. So if that is the case, because 20 marks is the first question, and losing like all of them is wrong. So getting 18 is pretty good, right? That's right.
Yeah.
Wheatstone Bridge, like Wheatstone Bridge. Yeah, multimeters, you do have multimeters, but you don't have to change the readings at all. I'll tell you. So somebody on YouTube is asking me about multimeters. Okay, multimeters is basically a device like this. Let me show you.
Is that in our syllabus?
No. In the practical, they will be given.
Yeah, we have those.
I like the ammeter and the voltmeter, but it's one device only.
So usually they have a ohm written here, ampere written here.
One with the ranges.
Yeah. So basically, what you just need to do is wherever the the knob is, if it's pointing towards this, you don't need to change. Never change it. Never change anything on this. Okay. If it's pointing to voltmeter, you know it's voltmeter. If it's pointing to say ammeter here somewhere, you say it's ammeter. Yeah, it could be ohm meter as well. But the point is, you don't change it. You know what reading it is, and then you can simply connect to whatever you're trying to connect. Okay. But that's something you will know already. So this is not a big deal. Anything else? You have an exam tomorrow for practical?
No, sir, Thursday.
Thursday.
All right. Okay. Okay. If you guys have any other questions,
They're the last 8 marks.
which last 8 marks? Oh, yeah.
That very long thing.
Yeah. I'll tell you what to do. In those questions, what you're gonna do is, you see, ideally, let's make a plan, right? The plan is that usually 32 to 33 above is an A in this. Okay. Now you got total of 40 marks, right, Anusha?
Yeah.
Let's suppose, yes, it will be already, yes, in quoted black, it will be already there. So let's suppose you have, this is the total mark. So let's make a plan. So in question 1, you have no problem. You can actually score 20 out of 20. Let's suppose you take supervisor help, you get 18, right? Let's suppose in the worst case scenario. And then in question number 2, it's pretty simple. If you know how to, estimate the uncertainty, you do all the parts correct, that's fine. So when you reach the last part, which is actually the 8-mark part, so 4 here, 4 here. So first is always the 2 values or 2 readings, whatever you write, is not enough to draw a valid conclusion, right? So you already get 1 mark. And then the remedy for this is that take multiple values or more values and plot a graph of best fit, right? Do not write take average because that would be wrong. So in the 4 other, you get 1 mark, right, Anusha? Let's suppose you get these all wrong. So basically, you're still gonna get 14, correct? So 18 plus 14 is 32. That makes an A. Do you understand?
No, but
Even
I don't
if you-
want them to be wrong.
Yeah, see? So basically, and that's not possible that you get 6 marks wrong here. Now, the idea behind this is that when you're doing it, you will see, let's suppose it's like a question about a bucket, right? So in a bucket question, there's water and there's like something oscillating. So the bucket is not completely transparent, so you have an issue, right? So you will write, you will never say the bucket is not transparent. You'll say, what is the issue with this? You'll say, cannot see the maximum displacement made or cannot see the equilibrium point reached while taking the time period because the bucket was not transparent. Do you understand like that? So basically what you do is you always state the problem and then you have to tell what it is, like where is the uncertainty in the value, right? So value of maybe the time. You could then say, okay, the bucket was touching here, so it was not exactly vertical or touching the side, so you should take a bigger bucket and something like that. So the thing is, it's not possible that you do not get at least 1 mark, right? So even if you are threshold for paper 2, well, everybody says that they did really well, so I think the threshold will be high, but not too high. I think it will be around 45, 40, maybe not more than 45. Anyway, so I was saying that you always need to understand that the point of this is that you need to score around more than 32 and more. So if you do that, you get get A in this. Do you understand what I'm saying?
Yeah.
Now, one more thing that I want to tell you that I don't think I told in the video as well. And that is, never ever stop writing points. So what I'm saying is, you could actually write two more here as well that you think might be correct. Now, the thing is, the examiner will always favor the person who has written like 6 points and they're like 3 wrong and 3 right. even if they're not between the lines, right? So you're not written on the space given, but they're still there. So he's going to consider the ones which are right. He's going to ignore the ones that are wrong. All right, so somebody is asking, sir, what can the errors and improvement for something that has corks in them? I saw the lab personnel having corks and clay with them. So what could be the possible experiment? I don't exactly remember the anything related to that really. The best, there was a putty question where I remember there was like a measuring cylinder or a beaker, something like that. And then you had to put a putty around it, and then you have to balance something on top of it. So there was something like this that I remember, but not exactly something that was related to cork. If I find something, I'll try to do it. I'll post it. Okay, anything else? Anything you would like to ask?
Sir, the uncertainty thing in question 2, how do you do it?
Uncertainty question.
Yeah, the one in the practical question 2. You take a measurement, suppose, and then it asks you, give the uncertainty in your measurement.
Yes, that question. I tell you how. So basically what you do is, let's suppose there was a question that I remember, that you had to drop a tennis ball, or not the tennis ball, table tennis, ping pong ball, and then it would go like this, okay? And come back. So you had to measure the height here. That I remember. So first of all, you should remember that in the ruler, there is already an uncertainty of 0.1 centimeter, right? That's the issue with the ruler. So that's the precision, like the least count is the uncertainty. And now you think about it this way. So how many errors were there? So first of all, I thought it like this. I was like, it hit the surface. The surface was not actually pretty plain. So I added 0.1 again. Do you understand?
Yes.
Okay. And then I thought, okay, because it is moving too fast, so I can't really see exact reading. So 0.1 there as well. And then I thought, maybe because it's going sideways, so it also, affects that. Well, it does not really affect that, but the thing is, I added like one more to it because I was not sure, but it has a bigger range. So the total would be 0.4 centimeter, right? And divide by whatever the height was that you calculated, times 100%. That would give you the right answer. Do you understand?
Yes. So when do we use the least count of the ruler itself?
Least count of the ruler. When do you add it? What do you mean by that?
Like, suppose we measured the length of a wire using a ruler, and then it asks, what's the uncertainty in your measurement? Then what do we write?
So basically, you're saying, let's suppose there's a question where there is something hanging, right? Something hanging, and he says length of this.
Yeah.
So I would add rulers reading uncertainty, and then I don't know exactly. Well, it is hanging in the air, so I don't know if I'm starting from the right position here. 0.1 here. I would say I don't know the center, so 0.1 here. And I don't even know whether the ruler is like this or ruler is like that. Do you understand? It might be slanted, right? 0.1 again.
Yeah, okay, got it.
Okay, so unfortunately, encoded, I never, we do get to know the experiment, like there are different guesses because there's internal report that comes out before the exam. but I don't think it's right to disclose any of that. Although I know what is coming, but I'm not going to tell you. So that's ethically not right. So, well, what I can do is I can find these things, similar papers, and you can look at that. But I can't really give you a guess right now. It's not ethically right. Okay. Yes. So I think it's, if you guys have no other questions, it's pretty late now. As you can see, 12:29 a.m. I got to sleep. So I will see you guys tomorrow.